Hello everyone, this is Streamer and welcome to Genius Math Minds. In this video, I will be solving 15 problems involving inequalities. So from basic, we will see two things. So number one thing is, if we have a negative sign, let's say negative x is less than 2. If we multiply both sides with negative, then we need to change the sign of the inequality, that is from less than to greater than or from greater than to less than. So that is one thing. The next thing is, if we take reciprocal, let's say we have 1 by x is less than 2. If we take reciprocal, then we have to change the inequality symbol. So that's two basic things about inequalities. Now let's start with the 15 questions. Now the first question. We have x minus 3 less than 2. So how do we solve this? Is add 3 on both sides. We get x less than 5. So this is the answer for this question. As we go through these questions, the question will get harder. So this is the first question. Now the second one. The second one is 2x plus 5 is greater than or equal to 10. So this is the next question. Again, do the same thing. Subtract 5 from both the sides. We have 2x is greater than or equal to 5. X is greater than or equal to, divide these numbers with 2. So we get x is greater than or equal to 5 by 2. So this is the answer for this question. Now the next question, the third question. Third question is minus 3x minus 4 is less than 2. So this is another question. So here we add 4 on both sides. So we get minus 3x is less than, keeping the symbol the same, 6. Now divide both sides by 3. Don't divide this with negative 3 because there is another step for changing the sign when we multiply with negative. So just do the division with the numbers. So we get minus x is less than 2. Now if we multiply both sides with negative, so we need to change the sign. So x is greater than minus 2. And this is the answer for this question. That's 3 questions over. Now we'll get questions that are a bit harder. So I know this is kind of a longer video than usual, but I wanted to do this. So yeah, so now the fourth question is minus 1 less than or equal to 2x plus 3 less than or equal to 2. So this is the next question. We can do the same thing as we did earlier. Just subtract 3 from all these things. We can just do this like this. So we have negative 4 less than or equal to 2x less than or equal to minus 1. Since 2 minus 3 is negative 1. Now divide all these with 2. We have negative 2 less than or equal to x less than or equal to minus 1 by 2. We can write this as this, or we can write as x belongs to, this bracket means this value is included. So negative 2 to negative half. So we can write this as this 2. So this is the fourth question. So these kinds of questions will be prominent when you are dealing with algebra. So that's why I have taken these questions. So the next one is fifth one, minus 7 by 3. So minus 7 by 3 less than or equal to 5 plus x less than or equal to 1 by 3. This is the fifth question. Again, doing the same thing. Subtract 5 from all these. So this we need to take LCM. Minus 7 by 3 minus 5. This will get minus 7 minus 15 by 3, which will give minus 22 by 3. So this is what we have in the left hand side. Now from this we can take x, since plus 5 and minus 5 gets cancelled. From this again we need to take LCM. So 1 minus 15 by 3, which gives minus 14 by 3. So minus 14 by 3. So this is the answer for this question. So the next couple of questions we will have modulus. Having modulus in inequalities is little bit different from those questions without modulus, because it has to take two cases. Because minus 1 modulus is equal to 1 and 1 modulus is equal to 1. So there are two cases. The inside of the inside number of the modulus can be negative. Also it can be positive. Both produces the same outcome of positive numbers. So that's the different thing about modulus. Okay, the first thing with modulus question is x plus 3 modulus of x plus 3 is greater than 2. Now we need to split this into two parts. First part is the positive side, that is x plus 3 is greater than 2. So x plus 3 is greater than 2, then this will satisfy this inequality. The next thing is the inside number can be from minus 3 to minus infinity. Because if the inside number is between minus 3 to minus infinity, then the number inside, that is the modulus of that number, let's say minus 3. If we put minus 3 between the inside the modulus, we will get 3, which will satisfy this inequality. So that's why we have to split this modulus term into two parts. The first part is the positive part, the next part is the negative part. That is x plus 3 is less than minus 2. Because the numbers less than minus 2 are minus 3, minus 4 and so on. So that's why there is a splitting when it comes to modulus. So now we'll just solve this as usual. Subtract 3 from both sides. X is greater than minus 1. So this is one thing, one part of the solution. Now here again, subtract 3 from both sides. X is less than minus 5. So this is another part. Now we cannot have both in a single notation. So what I will do is, x is a number less than minus 5. So we can write this as here. The another thing is, always use open interval when you are near the infinity sign. So this is this part of the answer. We don't have any equality symbol here, so we do not use this closed interval. So that's another important thing. Again, from here, x is greater than minus 1. So it can be from minus 1 to infinity. Now what we should do to do the same thing, or what will we do if we want to take this as a single notation is put a union symbol. So this is called union. So the value of x is this. The x value should be between or less than minus 5 and it is greater than minus 1. But minus 1 and minus 5 are not included, and that's the meaning of this notation. That's the thing about modulus, is that it requires two cases to be solved. Now the next question is 7th one. 2x minus 5, modulus of 2x minus 5 is less than or equal to 7. So this is another thing. Here again take the same 2x minus 5 less than or equal to 7. The next thing is, it should be less than or equal to 7, and this can also be 2x minus 5 can also be greater than or equal to minus 7. Because if we have minus 8 inside the modulus, then this won't be true. But if it is greater than minus 7, like minus 5, then that would fit this inequality. So that's why we want a number greater than minus 7. And that's the thing with this. For these for these inequalities, we can actually do the same expression, or we can actually use the same thing twice. The equation will be like this. So this is how we'll continue doing the same thing. Add 5. So we have minus 2 less than or equals to 2x less than or equal to 12. Divide all this with 2. We have minus 1 less than or equal to x less than or equal to 6. So this is the final notation for this question. In the previous question we had a greater than sign. So that's why we did two intervals. But this is just between minus 7 and 7. So that's why we did a single interval. Okay, next one. Next question involves fractions. So x by 2 minus 6, modulus of x by 2 minus 6 is greater than 5. Again we can do the same thing. So x by 2 minus 6 is greater than 5, and it can also be like minus 6 minus 7. The inside of the modulus can also be minus 6 and minus 7. So we can also put x by 2 minus 6 is less than minus 5. Because if it is less than minus 5, then we can say minus 6 minus 7, the same thing. So we will solve these two. X by 2 minus 6 is less than minus 5 and greater than 5. So we will solve this first. X by 2 is greater than, take this 6 to the other side, we get 11. X is greater than 22. So this is one of the answers. Now the next thing, x by 2 is less than, add 6 on both sides, 1. So x is less than 2. So this is another solution. So the solution here is x must be less than 2. So that will be like this. And x should be greater than 22. So 22 to infinity. We don't have any equality sign here, so we'll just leave it like this and we'll put a unit. And that's the value of x. Also, for each of these questions, we can also check if our answers are correct just by substituting the values. I will do that in the next question. Okay, this question. 9th one. I hope you can see the questions clearly. 3 is greater than or equal to 2 minus 3x. So this is the next question. So we can write this as we did earlier. We can write this as this, so it will be easier for us because that's what we have been dealing with earlier. So splitting this, less than or equal to 3. This can also be minus 3, minus 2, minus 1, which means it should be greater than minus 3. So 2 minus 3x is greater than or equal to minus 3. So these are the two parts. Now solve this as usual. Minus 3x less than or equal to, subtract 2 on both sides, we get 1. Again dividing with just 3 because there is a negative sign. Minus x less than or equal to 1 by 3. Now multiplying with negative, so we can change the inequality. X is greater than or equal to minus 1 by 3. This is one part of the solution. Now we'll get to this. Minus 3x is greater than or equal to, subtracting 2, we get minus 5. Now multiply with 3 first. Now multiply with negative sign first. So we get 3x is less than or equal to 5. Now divide by 3. So this is the answer. So what this means is, it should be less than 5 by 3 but greater than minus 1 by 3. So we can just write like this. From minus 1 by 3, it should be greater than x 5 by 3. So this must be the answer for this. Yeah, this is the answer for this. So this is okay. I told that I will substitute the values. Okay, let's take a number between minus 1 by 3 and 5 by 3. We'll take 0. Okay, if we substitute 0 here, so substituting 0 will give 3 is greater than or equal to 2. So that solves this. So that's one way of checking if our answer is correct. Okay, now the 10th question. We have reached the 10th question. Okay, the 10th question is 2 by x minus 1, modulus is for the denominator, is less than or equal to 5. So how do we solve this? Is 2 less than or equal to 5 modulus x minus 1. We can just multiply this here. So that's how we will solve this. Now take this or divide both sides with 5. So 2 by 5 is less than or equal to x minus 1. So this is how we will solve this. So now this has become a simpler equation. X minus 1 is greater than or equal to 2 by 5. So now split this into 2. X minus 1 is greater than or equal to 2 by 5. And it can take values like minus 2 by 5 and so on. So x minus 1 is less than or equal to minus 2 by 5. Should be less than or equal to. Wait a second. So 2 by 5 is like 0.4. No, it should be greater than minus 2 by 5, right? Okay, let's just see x minus 5. If we substitute like 1, will this work? Will this work if we substitute 1? If we substitute 1, this won't work. So it should be greater than. So x minus 1 is less than or equal to minus 2 by 5. So we'll try like this. So now again doing the same thing. 2 by 5 plus 1 will give 7 by 5. So this is one part. Now from here doing the same thing. Minus 2 by 5 plus 1 will give 3 by 5. So x must be less than 3 by 5 and greater than 7 by 5. Yeah, that's the answer. So x belongs to, since we have a equality sign here, we need to use the closed bracket. But here we have infinity, so we will use the open bracket for here and the closed bracket for here. So it should be greater than 7 by 5. So this is the value for this. Minus infinity to 3 by 5, you need 7 by 5 to infinity. So now we have dealt with some modulus problems. Now we'll just see some random problems. So the 11th question. So the 11th question is 1 by x is greater than or equal to 2 by 3. So how we will solve this is, first we can take the reciprocal. So that can be the first step. So x is less than or equal to 3 by 2, because since we are taking the reciprocal, we need to change the inequality sign. So this is one thing. So x is less than or equal to 3 by 2. So this is one part of the answer. The second part is, if x is any negative number, this won't work, because let's say we put negative 1 here. Negative 1 is not greater than or equal to 2 by 3. So this won't work. So x cannot be any negative numbers, or x can never be 0, because then it will become infinity. So the value is actually x belongs to 0 to 3 by 2. This is the actual solution for this. Because x cannot be 0, so there is an open interval, and x can be 3 by 2, so it is an closed interval. So the next one, the 12th sum. So this is an interesting problem, because 3x minus 2 is less than or equal to 0. But we know a modulus can only be greater than or equal to 0. We know that. because all the numbers we put inside a modulus will become positive. But this is given it is less than or equal to 0. Does that mean this has no solutions? No, because it can be equal to 0. So the only answer we have is 3x minus 2 is equal to 0. 3x is equal to 2, x is equal to 2 by 3. This is the only answer. This is an interesting problem because this has only one answer, but the previous problems had an interval of answers. So this is another question that is somewhat interesting. Now we'll get to the 13th one. So 13th question is x plus 1 by 7 is less than 0. So this is the question. Now if we see clearly, then we know this has no real solution. So no solution. This question has no solution because a modulus can never be 0, or now a modulus can never be less than 0. So that's why this question has no solution. There might be some questions like this which will be very easy, but it looks hard. So now we'll get to the 14th question. 1 minus 2x is greater than 2 minus x. So this looks different because it has x on or variables on both sides of the inequality. So what we can do is doing the same algebra we did earlier. So add x on both sides so we can get the variables in one side. So we get 1 minus x is greater than 2. Now subtracting 1 on both sides, minus x is greater than 1. Now x is less than minus 1 because change of signs, so change of inequalities. So the answer is x is less than minus 1. So that is the answer for this. So now we have come to the final problem, 15th one. Okay, so now this is a very interesting problem because we have modulus of modulus x minus 3 is greater than 2. So don't be intimidated by this problem because this is actually an easier problem. First we'll do, so this interval must be greater than 2. We have to split this into 2. Modulus of x minus 3 is greater than 2. The next thing is modulus of x minus 3 is less than minus 2 because again that this interval can have values of minus 3, which will also solve problems. Minus 3 is less than minus 2. So that's why we have this interval less than minus 2. Solving this the same way we did earlier. Modulus of x plus 3 is less than 1. Again doing the same thing here. Modulus of x, add 3 on both sides, is greater than 5. So we have two solutions, or we have two intervals. Does that mean this is over? No, because there is still a modulus in the question. So from here we have x is less than 1. X is less than 1 and this can also be negative 1 too. So this will be the interval because this is smaller than 1. So it should be between these. So this is the interval for this. So this is one part of the solution. Okay, from this we have mod x is greater than 5 and x can also be less than minus 5. Again, if we put minus 6 here, the interval will be good to go. They will be true. So that's why. So we have 4 intervals. So how can we write this? The thing is, just write this from minus infinity to minus 5. This will be one interval. Union. We have this interval minus 1 to 1. Union 5 to infinity. So this is the solution for this. Now we can substitute some values and we can check. First we'll take a number from here. Let's take minus 6. So if we substitute here, we get this will become 6. Now 6 minus 3 gives 3. 3 is greater than 2. So this satisfies. Now we take a number from here. The simpler number is 0. So if we put 0 here, 0 minus 3 gives minus 3. Modulus of minus 3 is 3, which is greater than 2. Again, is this satisfies? Now we have a number from here. We can put 7. 7 minus 3 is 4 and 4 is greater than 2. Again, this satisfies. Now let's take a number that cannot satisfy. Let's take number like negative 1. We will say negative 1. So modulus of negative 1 is 1. 1 minus 3 gives minus 2. And modulus of minus 2 is 2. 2 is not greater than 2. So this does not satisfy this. And that's how you will solve inequalities. And that's it about this video. I hope you enjoyed this video. I know this is a longer video than usual, but that's it. Thank you.